So I was just asking you guys what is the angle that lands who has an initial side at the positive x-axis, so that is 0 degrees, has its terminal side end at this location that is 2/3 of the way through quadrant 1. Yes, 60 degree. This is a 60-degree angle. What is the measurement of the angle that goes over to this spot? And realize that this spot is 1/3 of the way into quadrant 2. Yes, 120. And so what we can see with the unit circle is that the value of the sine of 60 degrees and 120 degrees, both of them are the square root of 3/2. And so that's why you want to be drawing horizontal lines with sine, because it represents the y coordinate. I'm going to talk about cosecant later. I'm going to start off with just sine and cosine. Now, cosine, because it represents x values, then if you're looking on the circle, and let's say I point out to you, let's look at this point right here. That point is halfway through quadrant 2, so I'm going to try and draw through that point. So that's a terminal side of an angle, where the initial side of the angle is again the positive x-axis. So the amount that ray has turned, what is that degree measure? If I go almost, careful on the counting, if I go through one quadrant and then half a quadrant more, how much is one quadrant? There you go. One quadrant is 90 degrees. Half a quadrant is 45 degrees. Adding those two together gives you 135 degrees. So if I asked you what is the cosine of 135 degrees, do you know the answer? Oh, is that sound raising a hand? How do I don't know how to use the raise the hand thing yet. How do I use raise the hand? What do I do? Oh, is that when I'm supposed to just say your name? Oh my gosh, no, don't everyone start. Okay. So I know, oh, okay. Okay, so Alec, you have your hand raised. Or you...
I'm still kind of confused on this subject.
Uh-huh.
But I'm trying to limp forward.
Oh, yeah. Listen, I do not expect you guys to actually leave today feeling like you understand it. This is going to take time. And I am willing to be flexible with the calendar to give you the time you need, because teaching this online it's been the thing that I have been most nervous about having to teach online. Yeah, I'm going to forego a quiz today because I've got to push the calendar back a full day already. So you guys can have the break of that. When we're ready, when I'm going to give you a quiz, I'll make sure to go over the material with you at the beginning of class so you're ready for it. So just so what I want to do is I want to help you to understand how this circle is created and how to use it. Because once you get used to this, then we're going to use the circles to create the graphs of sine and cosine. What's true? Memorize. Oh, I see a hand. Angelica. Stop. Cosine. Well, yeah, it depends on part of it depends on are you planning on continuing in math after this? Some people know 100% that they're not going into anything related to math or science, and this is the end for them, and they're going into statistics, and they're never going to go into this math again. That's in this class, even when it's in person, I allow tons of notes for the trig tests. I don't expect all of this to be memorized, but what I'm trying to do is create an initial understanding. So if you do continue on, you'll have an easier time memorizing what you need to memorize. If you know you're going to go on, you really should start memorizing some of the stuff. You'll be better off. But I also realize that some of you this is the first and last time you're going to see it. And I'm hoping that you can see the value of it and understand to an extent what it's all about. But the first time through trig is really not enough to get you strong and really strong and ready to manage it. You guys used to do a lot more trig in the old curriculum. And this was actually typically a starting point with doing trig. What I'm upset about is that the honor students see it once and then are expected to be able to know how to do it. And that is not normal. But anyway, moving on and sticking to the subject. So what I want you to kind of get in the feel for is sine represents y coordinates of these points. Cosine represents x coordinates of these points. And so if sine represents y coordinates, then lines where you have y equals a number. Like if I asked you to draw the line y equals 1, you would draw a horizontal line at y equals 1. And that would touch the unit circle in one spot. If I asked you to draw the graph y equals 1/2, you would draw a horizontal line 1/2. And that will show you the points on the unit circle that have that y coordinate. But what you really want to understand is that's telling you that if the terminal side of your angle intersects the unit circle at that point, so starting from 0, you turn and you hit this blue ray that I just drew, or this one you get to after going woo all the way. For those two particular angles, the value of their sine is 1/2. And this first angle is 1/3 of the way through a quadrant. So how many degrees is 1/3 of the way through a quadrant? Yes. Good. 30 degrees. Then the next angle that I'm drawing right here, this angle, it goes through an entire quadrant, 90 degrees, and it goes 2/3 of the way through the next quadrant, which is 60 degrees. Or you could look at it as, if you know 180 is right here, you have to back up 1/3 of the way, which is 30 degrees. And so what angle is this terminal side for? And I'm waiting for an answer. Which angle? This one right here that goes around. What is that? Or there you go, 150. So it's 180 minus 30 degrees, because if you start at 180 and you back up 1/3 of a quadrant, that's backing up 30 degrees. Whoop. I'm accidentally hitting buttons on my computer. So looking at this, what you're seeing is that the sine of a 30-degree angle is 1/2, and the sine of a 150-degree angle is also 1/2. Now, with looking at the sine and cosine alone, I want to take you through these examples where we are dealing with sine and cosine, and just those. There are so many. Oh, yeah. But what you ultimately, well, I'll start off with this. When you take tests, you're going to have a nice, pretty unit circle right next to you to use. Then if you keep going to the next math class, you will eventually learn how to draw just the portion of the unit circle that you need to think through. And once you really get the idea of the symmetry, you just have a few things that you understand are going on, and you can create the sine and the cosine of a variety of angles. So here we go. Oh, we just did 150. Let's do something else. We did 135. Perhaps I need to make some other examples. Yes, I'm going to make some other examples because we just did too many of those. So let's do, I've been sticking to sine too long. Let me go with cosine. So if I asked you, what is the cosine of, let me think, hold on, 300 degrees. 300 degrees. Now, you're going to have a unit circle in front of you. But I'm going to, in the meantime, help you to learn how to create what you need out of the circle. So 270 degrees. Do you feel comfortable with that number? Because, I know there are a lot of, okay, I'm not a skateboarder. I do not know that much. I just know that there are moves that are named off of how much of a rotation is done. So you've got the 180, but does 270 ring a bell for you guys? What? Yeah, exactly. And that's all based on this. And so 270 degrees, it's a number you want to get familiar with because it's 3/4 of the way around. So 300.
Halfway through the circle.
I think you're being a little bit sarcastic, but I'm not entirely sure.
Okay, I'm sorry. I have a naturally sarcastic tone. This is a serious
Okay,
question.
okay. So it's 270 because we humans decided that 0 degrees was going to basically be east, shall we say. And so if I take a ray and this is where it would be nice to, I might be able to do this. Let's see. Okay. Go where I want you to. It doesn't want to go where I want it to. Why do they always do this? Okay. I'm going to go right at the center. Okay, fine. Basically, this arm is rotating from the center, but I can't get it to start on the center because it decides it wants to start somewhere else for some reason. And we're looking at the idea of turning, starting at 0 degrees and making 3/4 of a circle of a rotation to 270. So you, uh-huh, yeah. And unfortunately, this thing draws weird. Okay, can I make you go where I want you to go? No, apparently. But yeah, it's basically turning around 3/4 of the way from what's considered to be 0. So if 270 takes you that far, 300 degrees is 30 degrees farther than that. And 30 degrees farther than that is 1/3 of the way from 270 to into quadrant 4. 30 degrees is 1/3 of a quadrant. 45 degrees is half a quadrant. And you really only need to know those two, but you can add on to that 60 degrees, which is double 30, which is why you don't have to memorize 60. But 60 degrees will take you 2/3 of the way through. You really only have to remember that you have 30 degrees and you have 45 degrees. And you can create all of these angles based off of that knowledge. So then,
Wait.
yeah.
Making angles out of the portions of the triangle that we have. Like, hey, I have, let's say, 180 and 230. I'd get a triangle out of that.
Well, what we're doing is we're going outside the box of the triangle, especially the right triangle. When you're dealing with a right triangle, you can only work inside of quadrant 1, and you don't even get to work with 0 itself or 90 degrees itself so much. So you're very confined when you are with a triangle. So some decisions were made about what sine meant on a right triangle, what cosine meant with a right triangle. Then the view got expanded. And we took these triangles, and what I'm trying to do here, oh, no, that's not the one. What I'm trying to do here, yes, is show you that in all 4 quadrants, it's these same special right triangles, just rotated or flipped around a little bit differently. What someone decided was um, that we could go beyond just an acute angle. And it was decided what was going to be 0 degrees and what was going to be the positive direction, because let me tell you, it could have been chosen differently, but a choice was made. If you think about, you guys know that in other cultures, people read differently, just as far as direction. You guys know that, right? There are other languages that read right to left, and all sorts of different ways. So, as language gets created, and math is a language, choices have to be made that we're all going to stick with this way. And so it was decided, as far as math goes, that when it comes to rotations, in order for us to be able to discuss rotations with each other, trying to draw a horizontal line, this would be 0 degrees, this would be the positive direction. But I will tell you, it is almost ridiculously, we probably came insanely close to someone choosing this to be 0 degrees. And then if that had been chosen, clockwise would have been the positive direction. Because, when somebody made clocks, that worked. And basically, somebody had to choose what was going to be a starting point and what was going to be a positive direction. You can make sense of that if you look at a horizontal line. Somebody had to decide, we're going to put a 0 and consider that the middle of the line. But then they had to choose which side is considered to be positive, which side is considered to be negative. And so that got chosen. And now we just always work with it. The y-axis happens to be the same number line, but vertical. And there a choice had to be made. We had to decide, is up positive or is down positive? And somebody chose up. And the entire mathematical community has chosen to embrace that as the universal, and so now it is. And that caused quadrant 1 to be the positive quadrant. With that being chosen, we needed to have 0 start at either the positive x-axis or the positive y-axis, and for a positive rotation to begin in quadrant 1, once these two had already been the universal accepted thing. But once this single idea was chosen of what's 0, what's positive, everything fell into place. And we can use symmetry to decide that what the sine function is going to do is it's going to follow the y coordinate of the rotation. And
that math is just built upon a lot of truths that people think is real, where there's no possible way to prove it, just prove that these methods are actually greater in the bigger scheme of mathematics.
100%. Absolutely, yes. I remember having that discussion with a professor once, and if I am remembering correctly, I believe it was Descartes who came up with a theory that it is possible, and not to, math usually stays out of the realm of religion, but just to kind of throw out there, he theorized that there could be some evil creator of the universe who is laughing at us, and we are actually doing everything the wrong way, and everything we do is based on a lie. And everything we know is wrong.
If there is a creator, if there was a creator of the universe, then wouldn't they have gone insane long ago? Didn't
You
they
know,
just
let's not go there. But yes, you are correct, Jason. If humanity had 12 fingers, we would have a base 12 system. It makes complete sense because I can't tell you how many times I trust the counting of my fingers. And I remember there was I don't know, the math department was asked to do something. All of us started counting on our fingers and people were shocked. And we're like, what? Do you think we magically put numbers together and they just come out? Yes. Yes. Mm-hmm. And that's one of the things that can help math to begin to make more sense is to realize that it had to have a spark of humanity creation as far as deciding how we were going to communicate the same information. I mean, why is it that you understand the words I am saying? A language was set up. The same has to happen in math. A language has to be set up. But once certain basics are set up, the logic takes over. And so once you understand how the unit circle is created, the logic can help you to not have to memorize. Yeah, absolutely. Yeah. You know, I'm still upset that I didn't learn how to click, and I will never be able to. You know how some language have a click sound, you know? Yeah. Anyone else feel that way? I'm not alone in that, I'm sure. Don't you wish you learned how to click with your language, or am I alone? Anyway, anyway. Um, as much as possible, we need math to be universally accepted through different cultures. And so there was definitely a lot of, if you go back, um, even now as we're on the forefront of new mathematics, decisions have to be made between people with different languages if we want to communicate with each other. Okay, now I'm going to stop with that and we're going to go back to the basics of what we're doing. So 300 degrees, you see where it is located. If I were to ask you what is the cosine of 300 degrees, you would be trying to figure out what is the x-coordinate of this point on the unit circle where the terminal side of 300 degrees lands. So we went new, 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 ding, and we landed. What is that x-coordinate? And this is why I have drawn these. And I'm going to erase. There we go. Erase a little more over here. So 300 degrees was 30 degrees beyond 270. And the x-coordinate of this point, what is it? I'm hoping for someone to answer that. What is that x-coordinate? You got it, 1/2. And again, these three x-coordinates that I just pointed out, these three right here, there are only 3 x-coordinates of a whole bunch of other x-coordinates that exist around this circle. These are just giving us some reference points to begin to build an understanding of all of the angles in between. we would go crazy if we thought about all the angles. But if we stop and just look at a few angles and hold on to those, then if we need to talk about other angles, we have a reference point or a reference angle to move around from. So the only numbers you have to remember are 1 over 2, root 2 over 2, and root 3 over 2. And what's nice about them is how beautifully they count 1, 2, 3. So you can literally count the lines from 0, 1, 2, 3, or the other direction, 1, 2, 3. But we know that these are on the negative side of the x-axis. So if I land at 120 degrees, the cosine is negative 1/2. If I rotate 135 degrees, the cosine is negative root 2 over 2. If I go, let's see, 150 degrees, the cosine is negative root 3 over 2. And if I decided to do a full 180, what is the cosine of 180 if we allow the logic to flow? And I'll get to tangent. I've got to first get sine and cosine down. So if we let the logic flow, yes, negative 1. The cosine of 180 degrees is equal to negative 1. Done. Now, let me actually move you over to your homework. How about we get some of these done? We can do them together.
Wait, let me go print it.
So if you don't necessarily look directly at a unit circle, but you're going to be able to. When it comes to this, what is the sine of 60 degrees? Using a unit circle. Okay, okay. 60 degrees is 2/3 of the way through quadrant 1. Sine is wanting to know the y coordinate. And this is where it's going to be a little bit easier if I go back to the circle. And I'm actually going to erase this out of here completely. I need a bigger eraser. Okay, good enough. Not good enough. All right, so what you want to realize is if you have turned 60 degrees, the y coordinate of that point is on the positive y-axis, and 1, 2, 3, it is the square root of 3 over 2. If you are asked what is the cosine of 45 degrees, you know that 45 degrees is halfway through a quadrant. Cosine is asking what is the x-coordinate of that point. So 45 degrees, and I actually want to use a thicker line. So 45 degrees, what is the x-coordinate of that line? It's on the positive x-axis, positive 1, positive 2, positive root 2 over 2. "90 degrees. So you want to know where is 90 degrees? Where does it land? And then cosine is the x coordinate of this particular point. That allows us to create a nice continuous function for cosine if we let the logic on the circle take over. So right here, the x coordinate is?
Wait, wouldn't 60 be more closer to the 90? Oh, wait, no. I just remembered how this circle works. More closer to the 90. Okay.
Okay, 90 degrees. So 90 degrees means you have gone from 0 degrees and really turned a right angle. You've turned this much. The ray of the terminal side of that angle intersects the unit circle at a point that has an x and a y coordinate. What is the x coordinate of that point? And I'm waiting to see what I get. You got it, 0. So the cosine of 90 degrees is 0. And all you have to do on these problems is write the number. You don't have to draw the circles, especially if you have a unit circle next to you. But what I'm wanting you to see is understand a lot better how these numbers are coming out. Are they? No. Oh, no, I don't have the homework answers up. You're looking at the classwork. And I just realized I probably confused you. And I probably should have done the classwork, huh? Instead of the homework. What am I doing? I don't know. So let's come over here and I'll stop doing the homework. 150 degrees for sine. You have to, yeah. So one. Shh.
Are we just doing the line or do we have
Um, all you have to do is write down the number answer. That's it. I realize right now that I probably should have given you a homework assignment with just sine and cosine first without all the others. But I've given you what I've given you, and I need to find a way to cope with that because I'm looking at 5 minutes left. So 150 degrees is 30 degrees shy of 180. And if I want to find the sine, that means I need the y coordinate of that point. And the y coordinate of that point is on the positive y-axis. And as you go from the origin, it's the first one of these three away. So it is 1, positive 1 over 2. For the cosine of 135 degrees, 135 degrees is an angle that takes you halfway into quadrant 2. Cosine is the x-coordinate of that point. So the x-coordinate of that point is on the negative side of the x-axis. And if you go from the origin, it is 1 to the second of those special coordinates from the origin. So it is negative root 2 over 2. Do you feel like you're getting the idea of sine and cosine? because I realize what I need to do. It's very different trying to get through this online, especially when we had a break right in the middle. So I'm trying to adjust, and you're, I guess, benefiting from this in that I'm going to push the due date further. Here's what I need you to do today. What I need you to do today is see if you can get through everything that is just sine and cosine on both the classwork and the homework. So I'm highlighting which ones that means. Go through today just the sine and the cosine. And you have nothing due today with no quiz. So
So no homework?
correct. Happy Wednesday.
Oh God, it's not even Christmas yet.
Okay, I've still got another minute and maybe a half with you. So bear with me. Does everyone understand that for today, your homework that you're not turning in yet is to go through and finish filling in sine and cosine? For the classwork, you have the answers accessible. For the homework, you do not have the answers accessible yet. Okay, so you've got the homework and the classwork. And with the classwork, just to emphasize, we did these two, and these are the only other four.
So wait, we're just gonna.
Do just those and call it a day.
Then I need a bit more like explanation on how to do these. So can I
Okay.
skip it after?
Absolutely. I'm going to just keep going, and it is technically still on the clock. You can bail when it turns 1:45. So 180 degrees means that you had started at 0 degrees and you made a rotation that caused you to land with a terminal side. I take it it's, yep, 1:45. I see all the people bailing. So 180 degrees lands you with a ray that has its initial point right there at the origin and comes out along the negative y-axis. But what you care about when it comes to cosine is what is the x-coordinate of the specific point that this intersects the unit circle at. So that ray at 180 degrees crosses the unit circle at one particular point. That point has an x-coordinate and a y-coordinate. Because this is cosine, you want to answer what is the x-coordinate. And so what do we get for the x-coordinate? And since there's so few people, you can feel free to speak. Anyone see it? This green dot right here, what is its x-coordinate? Maybe.
Thank you. Goodbye.
Bye-bye.
So to find the x coordinates, you just put trying to figure this out. Okay.
So let me remind you that this is a unit circle. And let me see. You know, let me just come over here to this. You have these special numbers of 1/2, negative 1/2 for the x-coordinate, negative root 2/2 for the next x-coordinate, negative root 3 over 2 for the next x coordinate. And when you finally reach this far end, the x coordinate there is negative 1. Because we're looking at the radius of the circle is 1. So all of the blue lines that you see drawn here, unless you're colorblind, sorry, each of the blue lines has a length of 1. Every single one of them has a length of 1.
So, let me get this straight.
Mm-hmm.
If we were to go to a point like, let's say, 135, we use square root of 2 over 2 to get our answer.
The square root of 2 over 2 is the y coordinate of that point, and that would be the sine. The x coordinate is negative root 2 over 2.
So, but we're going to use those two factors to get the main answer?
Yeah. And in fact, once you have sine and cosine, tomorrow I'm going to talk to you about how you get all the other 4 trig functions after that. So if you want to know what is the tangent of 135 degrees, do you remember when I said that tangent was sine over cosine? Excellent. So what you can do is you can find the sine of 135 degrees, divide it by the cosine of 135 degrees, and what number does that leave you with? What is that number reduced to?
I'm still kind of shaky on it using my calculator.
Oh, don't use your calculator, actually. Just sit back and realize that what you have is a number it's an ugly number, but we're not going to tell it it's ugly. That would hurt its feelings.
Well, you just did.
Okay, I did. But this number, root 2 over 2, is being divided by negative, the same thing.
So would it make it a negative 1?
Yep. And you know what else is interesting? Do you know what the slope of this line is? So if I have a line at a 45-degree angle, because depending, you can just look at it as it is something that is coming down at a 45-degree angle. Because usually when we talk about things, we put into context 0 to 90. But if I asked you to draw this line that goes through the origin, that's actually the line y equals negative x. And the slope of that line is the same thing as its tangent.
So it's just negative 1 and negative 1.
Mm-hmm. Yeah. I'm going to teach you guys, first, we're going to need to look at this. But I have found that the quickest way to use the unit circle with tangent is to recognize that it's actually the same number as the slope of the line that it's sitting on. And that has everything to do with the fact that sine represents y and cosine represents x. And what do we know about y divided by x? It's how we defined slope. So tangent wound up being defined in the same manner as slope is defined. And that creates all sorts of crazy connections on top of the trig. And so that's what some of us find so amazing about math, is how it just, once a few decisions are made about what we're going to universally accept to be zero, positive, negative, and what direction things go, it just takes on a life of its own. So, did you want me to keep going through? Oh, I'm supposed to start my office hours. Do you want me to keep going, Alec? Because I can, and just open up my office hours so I don't lose anyone, or I can at least make the decision to go help someone on office hours.
Please keep it open.
Okay.
So for 90, we would use the top line, right?
Hold on one second. I'm trying to focus on where I'm going through the internet to find people. Okay. All right. I'm in the middle of finishing something up with a fourth period student. Can you guys hold on a sec? Okay. And now I'm coming back over here. I need to be careful because I've got to balance students at this point. So what were you asking? Alec, what were you asking?
So for 90, we'd use like the top portion on the homework, like.
Right.
Okay, and then would that give us a zero or a one?
It depends on whether you're dealing with the x or the y coordinate. So 90 degrees lands you right here. And if you forget about sine and cosine for a moment and just see, that's a y-intercept. And it's located at y equals 1. So the y coordinate, which is sine, is 1.
All right, so if it's on any of the lines, it really kind of just depends on either if it's positive or negative.
Mm-hmm.
How 0 and 90 are positive, and 180 and 270 are negative.
Right.
So if it just said like cos 180 would be like a negative one.
Yes, that is exactly it. And if you were asked about, my pen stopped being, okay, so
If it says one of the lines, like, hey, 180 is not sin.
Well, here's the thing. The angles take you to a position. Sine is looking at what is the y coordinate. Cosine is looking at what is the x coordinate. So if you went to 270 down here, and I asked you, what is the value of sine of 270? You would look at the y coordinate. So what is the sine of 270?
So because it's
So you're looking at the negative side of the y-axis. The y coordinate.
So would it be 0 because 0 is on the top?
That would be the cosine.
All right.
So, uh-huh.
If it's, so that means that if it's so if it's cos, it would mean that it's just like the blatant, hey, here it is, that's the thing. But for oh, that's okay. Just throw.
It's an issue of the x coordinate is the cosine of that angle that lands there. The y-coordinate is the sine of the angle that lands there.
Okay, so it just depends on if it's x or y.
Uh-huh. Yep. The x-coordinate gives you the cosine. The y-coordinate gives you the sine.
All right. So what about sin 300? Like, okay, now that I understand, like, hey, if it's on the line, it just depends if it's
Right.
x or y.
Okay.
But now, how do we?
So you said,
How do we do it if it's not on the line?
okay, so sine of 300, you said?
Yeah. Suppose
So
like I make
3,
the circle,
uh-huh,
I make the x, and because it's like a bit in front of 270, I'd say
uh-huh,
it's around like the first dot.
uh-huh,
Will we calculate that with the first dot's x-axis?
uh-huh.
And if so, how would we do it?
So with 300 degrees, you look at what is the x-coordinate, especially compared to the other ones. It's the first of these dashed lines. So it's 1 over 2. And because it's on the positive x-axis, it's a positive number.
So then we look on the map. What's that? The sin and
Uh-huh.
cos.
So if I asked you what is the sine of 300 degrees, you would look at what is the y-coordinate of this point in space.
Oh, okay. So with the degrees, it's just like, hey, is it that x or y? Sin means that it's y. X means that,
Uh-huh.
but it's cos.
Right, right. The angle takes you somewhere, and then cosine asks what's the x-coordinate here, sine asks what's the y-coordinate here.
So sin would be one, or 300. Sin of 300 would be one. Correct?
The sine of 300,
Yes, that'd be one.
if you want to look at the fact that it's on the negative y-axis, and it's not all the way down at the bottom. It's how many of these dashed lines from the origin.
All right.
So it's 1, 2, 3 away. So it's square root of 3 over 2.
And that'd be its answer.
Negative, I forgot negative. Because it's on the negative. Yes, that would be the answer.
So
And then the cosine of the 300 degrees would be asking what is the x-coordinate at this point, and it's on the positive x-axis, and it's the first one away from the origin, so it's positive 1 over 2.
so
Uh-huh.
top number and final answer equals how many dash lines it is away from. Like
Uh-huh.
by that I mean like if it's from
Right.
the x, if it we start at the middle, if it's
Uh-huh.
let's say I'm gonna say 220. Let's say
Mm-hmm.
it's 220 because
Mm-hmm.
that's a bit. It's like I'm gonna say it's more closer to like 270, so it'd be more of a third dot around there, a bit more forward.
So
So
there,
that means
uh-huh. Okay.
that
Are you saying somewhere about here?
yeah, somewhere.
Okay.
So that would mean that it's more of like there's a four because it passes by three lines. It'd be square root 3/2.
So you're talking about the sine of that angle?
Yeah.
The sine of that angle, this angle doesn't land on one of these specific dots. But what you do know is if this dot right here, if its y value is negative root 3 over 2, and
Then that would be negative.
well, um, it would be between negative root 3 over 2 and negative 1.
All right.
And when you get in between those angles, that's when you need a calculator. what the circle allows you to do is understand what's actually going on and give you a feel for number placement.
So it just gives you kind of like a quick way through certain numbers.
Yes. Yes. And it also aids you in understanding what actually is going on when you're first learning it.
Sorry for taking up a bit of your time.
No problem at all.
Thank you for helping me understand.
Absolutely. I was glad to help you.
This tomorrow. That's okay.
What?
We'll talk a little bit more about this tomorrow.
Oh, yes, definitely. Yeah.